Emily Lakdawalla is the senior editor of Planetary Society, a non-profit organisation involved in astronomy projects. She was at the mission control earlier and joins us on the line now from Darmstadt in Germany. Emily, thanks for being with us. We'll talk about the details of what's gone on since it landed, but I just want you to sum up for me how you were feeling when you got the news that this was a mission accomplished.
It was absolutely incredible. You know, I don't think in my heart I really expected it to succeed. And the fact that it succeeded and the lander returned data and is still returning data as far as we know is absolutely beyond my expectations. And it's just such an amazing accomplishment for the European Space Agency.
This has been waiting for a long time, a number of years. I know that you've been covering this as well for some time. Did you think it would happen? You can tell us the truth now, by the way.
No, you know, I believed it would happen. This lander was going to hit the comet no matter what. But the fact that it survived is just incredible. And just hearing at the top of this broadcast all of the celebrations of the people all over Europe that this thing that they've worked on for so many years has succeeded, it's bringing it all back. It just was a tremendous experience.
So let's get down to a bit of detail. Those anchoring harpoons did not fire. Are you concerned in the ability of the lander to actually stay on this comet now?
Well, I'm not concerned about its ability to stay on the comet. As small as the comet is, it does have gravity, and the lander will stay down there somehow. There are a couple of experiments that may not work very well if it's not anchored firmly to the surface, in particular the drill. However, any amount of data that this lander has sent back from the surface is more than we have ever achieved from any mission before. Nothing has ever landed on a comet before. Even if the lander shut down at this moment, we would already have learned a great deal more about comets than we ever had known before. So it's just an immense achievement.
Let's say, though, that in the best case scenario, things do go according to plan in the next 24 hours or so. You spoke of the drill. Just for our viewers, can you just talk through what you mean by that and what that experiment is all about?
Sure. Well, one of the main things that we don't understand about comets is when you have an object that begins its life very far out in the solar system, and then it comes into the inner solar system, you have something that's made of ice and dust and all this material, and then the ice goes away. And what's left behind could be this weird fairy castle matrix of dusty organic material. And how it's all put together is actually really important for how we assemble planets and other objects in the solar system. And the fact that we don't know how that surface is constructed, how it works, it's a big gap in our understanding of comets. It's also crucially important if we should ever discover a comet or an asteroid that's on course to hit the Earth. If we want to be able to deflect such a thing, we have to know how its surface is put together. Can we grip it and move it? Do we need to find some other way in order to get it out of our path? So understanding these surface properties is really crucial. The drill will help us begin to understand that, will help us understand what the internal structure of this thing is like, how much heat is coming from the interior, what the composition of the interior is. There's so much we have yet to learn, and I'm looking forward to the results.
Yeah, you're going to be glued to those data monitors, aren't you, Emily? For now, thank you very much for joining us. Emily Lakdawalla there, thank you.
My pleasure.